Welcome everyone. Guys, in this video, we are going to know how to draw an enthalpy cycle. So I will give you a set of, or I will give you steps by which you can write any enthalpy cycle for any reaction. Okay. So usually, guys, in enthalpy cycle questions, you are given a certain reaction. And from this reaction, for this reaction, you have to write enthalpy cycle, and you have to find usually a delta H or enthalpy change for this reaction from the enthalpy cycle. So we have steps by which you can tackle these equations. The first step, guys, write over the arrow of the reaction delta HR. Okay, enthalpy change of this reaction. We don't know what's the exactly delta H for this reaction, so we write only delta HR. The second step, or the next step, is we just need to select reactant side or a product side. And we write all the elements that make these sides down here, okay, down below. We write the elements in elemental form down below, okay, of the reactants or products. It doesn't really matter. So I will select the products. So in the products, as we see, we have 2 sodium atoms. So we write 2 Na. Sodium is a metal, so we write only Na. Plus carbon, we have 2 carbon atoms, so 2 carbons. Plus we have the next element is oxygen. So how many oxygen we have? 3 here, 2 here, and 1 here. So we have 6 oxygens. But guys, we don't write 6O. Oxygen is diatomic molecule, so we have to write it like O2. And we have 6 atoms, so we have 3O2. What are the diatomic molecules? We have 7 diatomic molecules: H2, N2, O2, F2, I2, Br2, and Cl2. These are diatomic molecules, okay? So we have to write them like this. This is the second step, but it's not over yet. We have also hydrogen, 2 hydrogen atoms, so we write H2. It's diatomic. This is the second step. The third step, guys, you have to write arrows from the elements toward the reactants and toward the products. Okay, we need to write arrows from the elements to the reactants and the products. What are these arrows? These arrows, guys, represent the formation of the reactant from the elements. Okay, it represents the formation of the reactants and the products from the elements. Okay, it's not that difficult. So, for example, let's talk about H2O. H2O is made from oxygen and hydrogen. Just think about it like this. Over these arrows in the step 4, we have to write delta H's over this arrow and this arrow. We need to write delta H, sorry. We need to write delta H's. So let's talk about this arrow. Which delta H's should we include in here? What do you think? Delta H if of formation of what? This is delta H of formation of H2O, guys, of H2O. Okay, enthalpy change of formation of H2O. So this arrow represents enthalpy of formation, enthalpy change of formation of water. And also, it represents enthalpy change of formation of CO2, right? Because on this side, we have also enthalpy change of CO2. We have CO2 on this side, plus enthalpy change of formation of Na2CO3. This is, guys, step 4. And step 4, we have, and step 3, sorry, we have these arrows. These arrows represents the summation of these delta H's, okay, of formation of the product. On the other hand, we have the reactants. In the reactants, guys, we have NaHCO3. So delta HF of NaHCO3. That's it. But there's something here, guys. As you see, this compound has 2 moles multiplied by 2. So delta HF as well will be multiplied by 2. Okay, so for example, if we had here 3, we would multiply the H2O by 3. That's it. And step 4 is over. So in step 1, we write delta HR. Step 2, we write the elements. Step 3, we write the arrows. And step 4, this is the most important thing, guys. In step 4, we only write what this arrow really represents. Okay, so these arrows represent delta HF of products and reactants, as you see, the values. So this is, guys, the enthalpy change, enthalpy cycle. We will have more past paper questions in the next few minutes. But now let me show you how can we find delta HR if we have values. So most of the questions not only about writing the cycle, but it's also about finding the value. Okay, so let's have a look. Just 1 second. Right. So you will have a set of data like this, and from which you need to find delta H of reaction. Delta H of reaction, this delta H. So guys, look, to find delta H of reaction, let me show you something. Here we have this arrow, as you see, this arrow goes from the elements toward the reactants. And this arrow also goes toward the product. As you see, guys, these 2 arrows, let me say that they are moving in the same direction. They complete each other. They are different from this one, right? They are different from this arrow. So what I mean by different is that this one moving in this direction, and then this one completed. Okay, it's moving like this, right? So let me tell you something, guys. Whenever we have something like this, or you always will have 2 arrows in enthalpy cycle, they both go in the same direction. Okay, it doesn't really matter if they flip the cycle or make it more complicated, but you always have 2 arrows go in the same direction. So as you see here, let me repeat. Sorry. Yeah. As you see here, this reaction goes to the, the elements go to the reactants, and reactants go to the product. 2 arrows go in the same direction. Any delta H over these 2 arrows will be added, okay, together. Their values will be added together. Any delta H over this arrow will be added together. So what do we have on this arrow? We have 2 multiplied by delta HF of what? Of NaHCO3. We add it to what? In step 1, we draw delta HR. So we add it to delta HR. And yeah, we're done. After adding them, the delta H's over the arrows in the same direction. After adding them, we write equal sign, and we put the delta H's that are on the opposite arrow or the next arrow. Name it as you wish. Okay, we write equal sign, and we add the values of these delta H's here. So here we have delta HF of H2O plus delta HF of CO2 plus delta HF of what? Of Na2CO3. Okay. Now, guys, you have the values here. You need just to substitute the values with the delta H's. So you can say 2 times what? Delta H of NaHCO3, which is minus 950.8 equal, plus delta HR equal to what? Equal to delta HF of water, which is minus 285.8 plus what? Plus minus, for CO2, it is 393.5 plus minus the Na2CO3, which is 1130.5. Okay, and by this, guys, you can find the delta H of reaction. So this was example from the book. Let's see how the past paper questions look like. Welcome back, guys. So here we have a question. Just 1 second. Welcome back, guys. So as you see here, we have a past paper question. It's 2018, October. Paper, I think, 21 or 22. So here we have this question. We will draw an enthalpy cycle for it, and then we will find delta HR. So guys, whenever you are finding delta HR, from delta HF values, follow these steps. Firstly, guys, the first step was writing delta HR over this reaction. And we don't know what exactly is this. Okay, even me, I don't know which delta H is this. The second step was to write the elements that make this reaction. So which elements make this reactants, let me say, which elements make the reactants or the products? Which elements make them? Okay, so I will select the reactant side this time. So let's see what do we have in the reactant side. In the reactant side, we have 1 carbon atom. So C. We have how many hydrogen? We have only 1 hydrogen atom. So I would say H. Is that correct? No, it's not correct. Hydrogen is diatomic, so it must be H2. And to have 1 H, we write half H2. Okay. Then we move to, let me say, iodine. Iodine is also diatomic, so we have a 3/2 I2. So here we have 3 iodine atoms, plus we have 3 Ag. Ag is monoatomic, it's metal. And we have also, 3 Ag. And we have also F plus, how do we write F? F is diatomic, so 3/2 F2. This is, guys, the second step is over. The third step, guys, we draw arrows from the elements toward the reactants and towards the products. The fourth step might be the hardest, I think. So we need to know, we need to know which delta H's we should write over these arrows. What delta H's we got to write. So let me say, We have delta H of formation of what? We are making CHI3, so we have delta H of formation of CHI3. What do we have also on this arrow? We got plus, we got AGF. So this is delta H of formation of AGF, right? But how many moles of it? We have 3 moles, don't forget, so we multiply it by 3. That's it. We don't have other reactants, so we move to the products. On the product side, we have delta H of formation of CH F3, right? Plus 3 delta H of formation of AGI. It will be multiplied by 3. Delta H of formation of AGI. Yeah, so this is step 4 now is over. The last step, we need to see where are the arrows that complete each other, or both of them, they go on the same side. So as you see here, guys, let me use different color. This arrow, this one, and this arrow, they go in the same direction. They complete in each other. So they go this way, both of them, opposite to this one here. Okay, so any delta H over these arrows, we should sum them, add them together. So we can say that delta H F of CH I3 plus 3 delta H F of AGF plus what? Plus the, yeah, delta HR, right? So we add the values of delta H's over these arrows, sorry, and we make them equal to what? To delta H F or on the next arrow. So delta H F of CH F3 plus 3 delta HF of AGI. And we are done. That's it. Okay, guys. Now we need just to substitute the values here. Instead of writing CH delta HF of CHI3, we can write only minus 182.1, right? Yeah, we just substitute the values and it's over. We can find delta HR. But don't forget, when you have something, for example here, delta H F of AGF minus 204.6 will be multiplied by 3 because we have 3 moles of it. Okay, guys? And that's it. Let's move to the next question. 1 second. Yeah. Here we have the last question. So don't worry about this arrow. Okay, it doesn't really matter. Here, guys, also this is 2018. We need to draw enthalpy cycle and finding out delta H of this reaction. Yeah, so what should we do? First of all, we write delta HR. Secondly, we select product or reactant side. So I will select reactant side this time as well. How many carbon we have? Let's start with carbon. So we write them. 1 carbon plus. How many hydrogens? Here we have 1. Here we have 2 hydrogens. So this is 3 over 2 H2 to have 3 hydrogens atom. We have 3 chlorine atoms, so we have to write 3 over 2 Cl2. Don't forget the 7 diatomic molecules. Yeah, and we have also fluorine. It's F2 only because we have two of it. Okay, so did we miss something? Yeah, it's great. 3/2 Cl2 and F2, yeah. After that, guys, the next step, step 3, just to draw the arrows, easy peasy. We draw the arrows this way. And then we need to know which delta H's should we write over these arrows. So let me say that here we have delta H of formation of CHCl3 plus what? Plus 2 times delta HF of what? Of HF. And we are over from reactant side. And the product side, we have delta HF of CHClF2 plus delta HF of HCl, right? But this one should be multiplied by 2, sorry, because we have 2 moles of it. Okay. As you see here, guys, 2 arrows are going the same direction. Don't, as I told you, don't panic because of the reversible reaction. 2 arrows going the same direction. So here we have to write this side plus delta HR, making it equal to this side. Okay, so it's going to be delta HF of CHCl3 plus 2 times delta H formation of HF plus delta HR equal to these things here, okay? Just substitute the numbers and you can find delta H of reaction. Hope, guys, now you can draw enthalpy cycle, but don't forget, this is only when we need to find delta HR from delta HF. We have another enthalpy cycle, but it would have the same idea exactly. Okay, we'll take them in the next video. See you.